Okay, guys, just a couple of things we want to do to warm up here. First thing we want to do, if f of x is equal to x squared, we want to find each of the following. So the first one, we want f of x minus 2, and what this means is wherever you see an x up in this equation, you're going to plug in an x minus 2. So f of x minus 2 is going to equal the quantity x minus 2. I plug that in wherever I see an x, and it's that thing squared. Here's where we have to be careful. This thing is equal to, this is not the distributive property, guys. You do not distribute this exponent to each one of these on the inside because it's subtraction. These are two separate terms. If it happened to be maybe 2 times x on the inside, and there's an exponent, then absolutely that exponent gets applied to both of those. But that is not the case here. We've got a subtraction sign, so you've got to be careful when you apply that that exponent and what you're applying that exponent to on the inside. So what does this mean? Well, this means I've got 2 of these multiplied together. So just like x squared is the same as x times x, this right here means I've got whatever's inside the parentheses, whatever's being raised to that exponent, I've got 2 of those being multiplied together. So I've got the quantity x minus 2 times the quantity x minus 2. And this is a whole different problem from just taking this exponent and applying it to each one of these. This is actually a FOIL problem. So we go first outer, inner, last in order to expand the product of these two binomials. We've got x times x is x squared. Our outer is going to be x times negative 2. Our inner is going to be negative 2 times x. Combine those and you end up with a negative 4x. And then the last is going to be negative 2 times negative 2, which is positive 4. So f of x minus 2 is going to be equal to x squared minus 4x plus 4. F of x plus 2, essentially what we want to do is just take the output and add 2 to it. So what that means is I didn't do anything to x. I didn't change x at all. So I'm just going to bring down this whole expression for f of x, which is x squared, and add 2 to it, and we're done. So f of x plus 2 equals x squared plus 2. F of 2x is any time I see an x, I'm going to plug in a 2x. So f of 2x is going to be equal to, I see an x is being raised here, so I've now got 2x raised to the second power. And now this is the case where we can take this exponent, the 2, or the square, and apply it to both of those terms because we're multiplying here. So f of 2x is equal to 4x squared. So this is a nice little reminder of how we evaluate for particular inputs and or outputs, how we can change input and output. What we want to do now is relate what we call parent functions to kind of what we can do with those functions and how changing the input or the output changes the functions. All right, so what we're going to do is in GeoGebra, we're going to look at the graph of f of x equals x squared. Let's go to GeoGebra. I've already put in f of x equals x squared. I encourage you to do this yourself in GeoGebra, just so you know how and you get some practice applying or working with GeoGebra. So we've got f of x equals x squared there. We're going to come back here. We said that f of x minus 2 from the previous slide is going to be equal to x squared minus 4x plus 4. So what I want to do is we should have a general idea what this thing looks like just based off of this. Based off of what we learned before about transformations and more particularly shifts, we know that anytime you change the input here we're subtracting 2 from the input. This is the one that's opposite that you have to be careful of. But you're going to move it in the opposite direction, but this is just a shift right. So f of x minus 2 is just going to take whatever that parent function is, and in this case this is the most basic parabola. Go back and we'll show that shape here in a second, but this is the most basic parabola, f of x equals x squared, and if you're looking at f of x minus 2, it's just going to take this parabola and shift it right. So let's see what that looks like on a graph. So So what we want, again, we already simplified that algebraically. When we simplified it algebraically, we came up with this expression, x squared minus 4x plus 4. So let's enter that into GeoGebra. And when you do that, you come down here on the graph, and you can see from your graph, here's our original, the parent function, f of x equals x squared is in the green. In the red, we just took that parent function and shifted it right. And that's exactly what we talked about before with how these shifts work. If you change the input, this is going to shift it right. All right, so all we want to do is we want to look at what happens with these other two. F of x plus 2, well, we know generally that this is going to be a shift up 2 units. So let's go check out what happens to our graph. Again, we already simplified this. When we simplified it on the last page, we ended up with x squared plus 2. So that's the function that we want to graph. Go down to GeoGebra, and let's go ahead and get rid of this function just so we can simplify it a little bit. We want x squared plus 2. And now let's take a look at the graph. And again, in the green is the parent function, f of x equals x squared, the most basic parabola. This parabola has the same exact shape. It's just shifted up 2 because of how we transform the function. Last one here, f of 2x. And when we looked at f of 2x before, what we said was this is called a dilation or a stretch. And let's take a look at what happens on the graph. F of 2x, we simplified that before on the last page, and we ended up with f of 2x equals 4x squared. So when we stretch this, we get something algebraically that looks like 4x squared. But on GeoGebra, we get something that looks like this. Oh, where'd it go? There's 4x squared. So what we did was we essentially stretched it upward. The vertical stretch, we just stretched it upward and pulled that upward. You can see it has the same vertex. We basically made it more steep. Made these lines more steep. Alright, so we talked a little bit about how we can change that quadratic or that parabola by manipulating it algebraically. So what we want to do now is what other types of curves are out there? What other types of functions are out there? The most basic functions are linear functions. Those are lines, as the name kind of indicates. And the general form for that is f of x equals x. This is the parent function. This is the most basic line. Okay, the most basic line. It has a slope of 1 and a y-intercept of 0. So it crosses right at that x-axis. Looks something like this. Slope of 1, up 1 over 1. Alright, so we can take this and algebraically, let's say we look at f of x plus 1. Let's go back to our graph here. Let's go ahead and get rid of all this stuff. Now we want the parent function to be x. Just x. Here's our function. See, it's got a line that passes through the origin. And we want to do f of x plus 1. Well, what happens everywhere we see an x? We plug in an x plus 1. Well, we know that what that essentially does is shift it left 1 unit. So now here's the intersection. We shifted that line left 1 unit so that now it crosses that x-axis at -1. So again, this is the linear function family. Okay, we can shift it left and right. We can shift it up and down. We can kind of stretch it. When we stretch it, basically what it does is increase or decrease the slope accordingly. All right, the next family of functions or family of curves are the parabolas or the quadratic. That's the one we just looked at. So we look at f of x equals x squared. This is the parent function. Oop. And we just mess around with a bunch of those graphs right there for that particular one. Last one that we're going to take a look at here is the cubic, the cubic functions. Parent function looks like this: f of x equals x cubed. All right, let's go back to our GeoGebra here. Start a new one just to give you a nice fresh page here. The cubic functions look like this: x cubed. We're going to come down here. Let's take a look at what these things look like. These things basically look like, on the right side of 0, for the positive x's, they look kind of like a parabola, but for the negatives, that thing actually flipped over. It's reflected across that x-axis. So when it becomes negative, it flips over that x-axis and gives you a kind of a curve like this that approaches 0, crosses at 0 at the origin, and then increases from there. So we can mess with these cubic functions. Say let's look at f of x plus 2. Plugging in x plus 2 wherever I see this, x plus 2 cubed. And remember, this is equivalent. Do not apply this exponent to each one of these and get x cubed plus 2 cubed. That's not how these work. What this is equivalent to is x plus 2 times x plus 2 times x plus 2. And let's see what we come out with here. This is going to be x squared plus 4x plus 4 for the first part, for those first two binomials being multiplied together, and then multiply that out, and I'll do this real quick. It's x cubed plus 2x squared plus 4x squared plus 8x plus 4x plus 8, and you simplify and you get x cubed plus that should be a 2x squared, sorry, 6x squared plus 12x plus 8. So this is what we're going to plug in to GeoGebra. And there you see it on the graph. So pretty cool. Just a shift again. Algebraically, it gets kind of ugly. There's a little bit of work to be done, but we know when we plug this in, this x plus 2, when we plug this in, it's just going to shift us left. It doesn't matter whether we're talking about a line or a parabola or a cubic. That's kind of the nice thing about algebra. It's got all these patterns, and one of the patterns is we know what happens if we add 2 to x. We know what happens if we were to take like f of x plus 6. So let's go x cubed plus 6. What happens there? Well, this should go up 6. Let's check GeoGebra one last time. We want x. Oops. I don't want a new name. We want x cubed plus 6. Let's go look at the graph. And what did it do? It just shifted this vertex up 6 units. Right? So we've got these families of functions. You've got linear functions, parabolas, cubics. There are a ton more we can go up. But they're all based on a parent function. For instance, f of x equals x is the linear parent function. X squared is the parabola parent function. The cubic is x cubed, and so on. And based on what we know about transformations, we can create all different types of these families of curves.